Hello and welcome to another lesson from Level Up Mathematics. In today's lesson, we will be exploring how to add and subtract radical expressions. Before we do, let's look at the steps to this process. So in step 1, you want to simplify any radical expressions that are not in their simplest form. In step 2, you'll identify like radicals. Now, like radicals are radicals that have the same index and same radicand. For example, if you have 4 cube root 2 and 6 cube root 2, these would be considered to be like radicals because they have the same radicand and they have the same index. After you have identified your like radicals, you'll simply combine the coefficients of those radicals. Now, let's look at a couple of examples how this works. In example 1, it says find each sum or difference. And in problem A, we have 2 square root 5, which is already simplified, and plus 3 square root 5, which is already simplified. Now, what I want you to notice in this problem is that they both have the same radicand, and they're both square roots. So that means that we can add these together. So I'm simply going to add the coefficients. So I'll add the 2 plus 3, and I'll keep the radicand the same. So my answer would be simply 5 square root 5. Now, in example B, we have 3 square root 3 minus 4 square root 2 plus 7 square root 3 plus square root 2. So the first thing I want to do is identify like radicals. So I have 3 square root 3 and 7 square root 3. If I combine those, I would get 10 square root 3. Next, we have negative 4 square root 2 and positive square root 2. Now, if it helps you, you can put a 1 right here. So we're combining negative 4 plus 1, which would give us negative 3 square root 2. And that's as far as we can go on that one, because these two radicals are not like radicals, so we can't combine them. All right, problem C, we have 9 square root 7 minus 2 square root 7. These are like radicals, so I'll just combine the coefficients. 9 minus 2 would be 7 square root 7. Now, problem D, we have 4 cube root 7 minus 8 square root 7 plus cube root 7. Now, if you'll notice, every one of these radical expressions has a 7 as the radicand, but the only two we can combine are the cube roots, because to be like radicals, they have to have the same index and the same radicand. So this would be 4 plus 1, 5 cube root 7 minus 8 square root 7. So make sure when you're combining them, they have the same index and same radicand. All right, in example 2, let's look at some that need to be simplified before we can add and subtract them. So in problem A, we have square root 8 minus square root 5 plus 4 square root 2. So if you'll look at this first radical, square root 8, that can be simplified to square root 4 times square root 2 minus square root 5 plus 4 square root 2. Now, I can break this expression down, this expression here. So square root of 4 is 2, so this would be 2 square root 2 minus square root 5 plus 4 square root 2. Now that everything is simplified, we can simply combine our like radicals. So let's combine 2 square root 2 plus 4 square root 2, and that would be 6 square root 2 minus square root 5. All right, problem B. 10 square root 27 minus square root 3 minus 4 square root 75. So I've got a couple of radicals here that I'm going to have to simplify before I can add or subtract them. So let's start with the first one. We have 10. I can rewrite square root 27 as square root 9 times square root 3. Then we have square root 3 is already simplified. And then on the third one, we have 4 times the square root 75. I can break down as square root 25 times square root 3. All right, now let's simplify that a little bit more. In our first parenthesis, the square root of 9 is 3. So 10 times 3 would be 30 square root 3 minus square root 3. And then here, square root 25 is 5. 4 times 5 is 20, square root 3. Now, just in case it helps you, I'm going to put a 1 here, because now we're going to combine our like radicals. So 30 minus 1 would be 29, and 29 minus 20 would be 9, square root 3. All right, problem C. Let's simplify this. We have 9 square root 12 plus 2 square root 32 minus 4 square root 72. So I'll break down this first radical. We have 9. Square root 12 could be rewritten as square root 4 times square root 3. 2 square root 32 could be broken down as 2 times square root 16 times square root 2. And then we have 4 square root 36 square root 2. All right, let's simplify that. Our first parenthesis, the square root of 4 is 2, so 9 times 2 would be 18 square root 3. My second parenthesis, the square root of 16 is 4, so 2 times 4 is 8 square root 2. And my last parenthesis, the square root of 36 is 6. 4 times 6 is 24 square root 2. Now identify your like radicals, so I can combine this with this. So my final answer would be 18 square root 3 plus 32 square root 2. All right, pause the video and try problem D on your own. All right, let's see how you did. I broke 2 square root 18 down to 2 square root 9 square root 2. I broke 3 square root 24 down to 3 square root 4 square root 6 minus 4 square root 6. And then 5 square root 50 became 5 square root 25 square root 2. So square root of 9 is 3. 2 times 3 is 6 square root 2. Minus square root of 4 is 2 times 3 would be 6 square root 6. Minus 4 square root 6. Minus 25 square root 2. So then I looked for the like radicals to combine. And I combined 6 square root 2 with negative 25 square root 2. And that gave me negative 19 square root 2. Then I combined negative 6 square root 6 with negative 4 square root 6. And that gave me negative 10 square root 6. All right, let's look at example 3. In example 3, we have 4 cube root 2 minus 2 cube root 54. Now, the first thing I want you to notice is we have cube roots this time. So, most people do not have their perfect cubes memorized. You may or you may not, but I'll write them down right here. 1 cubed is 1. 2 cubed is 8. 3 cubed is 27. 4 cubed is 64. 5 cubed is 125. We usually don't need any more than those, especially for this lesson. So we'll have those perfect cubes in case we need them. So the cube root of 1 is 1, cube root of 8 is 2, cube root of 27 is 3, cube root of 64 is 4, cube root of 125 is 5. All right, just in case we need them. So on the first one, we have 4 cube root 2. That cannot be simplified. So I'll write it down. Now, I feel like 2 cube root 54 can be simplified. So I want to see if any of these numbers will go into 54. And I notice 27 times 2 is 54. So I'm going to use 27. So this would be 2 cube root 27 times cube root 2. So 4 cube root 2 is already broken down. And then I'll break this down. Cube root of 27 is 3. 3 times 2 is 6. So 6 cube root 2. So 4 minus 6 would give us negative 2. Cube root 2 is our final answer. All right, let's try another perfect cube problem. So in problem B, we have negative 2 cube root 16 minus 5 cube root 128. Now, 16, I immediately notice that 8 will go into 16. So I'm going to rewrite this first radical expression as negative 2 times cube root 8 times cube root 2. And then I'll write the second expression as 5 cube root 64 times cube root 2. So the cube root of 8 is 2. Negative 2 times 2 would be negative 4 cube root 2. And then cube root of 64 is 4. 5 times 4 is 20, so this would be minus 20 cube root 2. Now we have radical expressions that have the same radicand and the same index, so I can combine them to get negative 24 cube root 2. All right, pause the video and try problem C on your own. All right, let's see how you did. I broke the first radical down as 5 square root 4 square root 2. The second radical was already simplified, so I didn't do anything to it. The third radical I broke down to square root 9 square root 2. And the third radical I broke down to 12 times cube root 64 cube root 2. All right, let's see what I can break down a little further. Square root of 4 is 2. 5 times 2 is 10 square root 2. And then we have 10 cube root 2. All right, my third parenthesis, the square root of 9 is 3, so this would be 3 square root 2. My last parenthesis, the cube root of 64 is 4. 12 times 4 is 48, so this would be negative 48 cube root 2. Now let's identify our like radicals. I can combine 10 square root 2 with 3 square root 2, and that will give me 13 square root 2. Then I can combine 10 cube root 2 with negative 48 cube root 2, and that would give me negative 38 cube root 2. And that concludes today's lesson on adding and subtracting radical expressions.